Hello and welcome to 5 Minute Math. Today we are looking at lessons learned from the 4th grade STAAR test 2023. My name is Aaron Daffern, creator of the 5 Minute Math video series, and we are looking specifically at the standards that are the readiness standards in which students scored 50% or less. So we will look at how the students answered and what that means for us instructionally. So let's start with the worst readiness standard on this last test. This was 4.8C, solving problems that involved length, time, volume, mass, money, just solving measurement problems. And you see that in both of these situations, take a look at number 6 and number 23. What we had to do here is we had to do some unit conversions. Okay, so the school had 30 gallons of lemonade, right? And I'll just solve it kind of in a short way, right? We had 30 gallons of lemonade. They drink 24 gallons and then 1 quart, right? So obviously drawing a picture might be a little bit easier than this, but if you want to subtract, we have to regroup. Problem is regrouping is a little bit weird, because if we take 1 gallon, it breaks up into 4 quarts, right? Not 10. So if we do it like this, okay, so then now it's going to make sense. We've got 3 quarts and we've got 5 gallons left. So our answer there is going to be A, but unfortunately, that wasn't even the most chosen answer, right? This one was actually the most chosen answer because they didn't necessarily regroup. And then we have the same thing here on number 23. Only 18% got this correct, right? We need to find the difference. So they just tell you straight up, subtract 4 pounds, 1 ounce. 1 pound, 9 ounces. If you need to regroup, that's fine, but remember this 1 pound is 16 ounces, so that turns into 17, right? So 2 pounds, 8 ounces. So our answer here is C. But on number 23, I mean, every other answer was chosen more than this. This was the least chosen answer. So let's see why exactly our students did that. So they had to regroup in these non-base 10 systems. They also could have drawn pictures, right? So probably a more efficient way to solve at least this one, right, would be to draw these 4 pounds, right, like this, and then maybe your little 1 ounce, and then try to take away, you know, 1 pound and then 9 ounces. Now you got to know that there's 16 ounces in there, so that's going to leave you with, 7 ounces. So I've got 7 ounces, I've got 1 ounce, so there's my 2 full pounds. And then I've got my 7 ounces left over. Some type of representation like that probably would have been a little bit better. And the answer selections for that number 23 indicated a lot of guessing. Kids just really didn't even know how to solve that, so they were just guessing all over the place. And like I said, the correct answer was the least chosen option, only 18%. So how can we as educators help our students here? First, we need to probably have them draw representations using arrays. The algorithms that I was using to solve it are good if you have a really solid understanding of how regrouping with non-base 10 systems works, but if not, I would definitely represent pictures, but not just pictures, arrays. If they use the grid paper that's available in the STAAR test and actually get the arrays, right, you can draw a 4 by 4 array and you can make this represent 1 pound because there's your 16 ounces. So taking away the ounces is a lot easier if you make an actual array. They just need lots of practice regrouping in non-base 10 systems, either subtracting or adding. As long as you have to regroup, that's fine. Or you can convert all your units into the smallest measurement, right? So another option here could have been, we could have taken our 30 gallons, right? We say there's 4 quarts in a gallon, so we can say, 30 gallons is 120 quarts. And then 24 gallons, well, you'd have to do 24 times 4, that's 96. Add that 1, it's 97 quarts, right? You could have, as long as you're doing this, right, we could have done, all right, that's 23 quarts. The problem is now you gotta put this back into gallons, right? You're gonna have to then divide that and get the 5 gallons and 3 quarts left over. So it is a little bit of extra work, but some kids might like that. So just give them options. All right, so our next one is 4.4H, and you see that we just got this one problem here, and it's a It's a two-step problem, but right, we have to interpret the remainder. Only 30% get it correct. So we've got ordering flour of 7 batches, 15 sacks of flour for each batch, right? So that's 15 times 7, that's 105. And then the flour comes in crates of 4. So I need crates of 4. How many crates of 4 do I need to get that 105? And then obviously you see the problem coming here. It's not going to be even, right? So I can get 26 crates, and that's going to get me 104. Okay, because 26 times 4 gets me 104. I don't need 104. I need 105. There's one left over. So I have to order that extra crate. Okay, so that means the answer there is going to be D. But you see here that B26 is also an option. And, that actually gets chosen a lot more, right? This was 45% of the students answered that, and only 30% chose it correctly. So let's take a look to see what that means for us, right? First off, it's a difficulty set problem because you have to recognize, and whether it be just by looking at the words or by drawing, representations, strip diagrams, whatever, you have to multiply, then divide. So whenever you have to do two different operations, it always raises the difficulty level. And then we had to interpret the remainder. What does that mean that we don't have enough? And the most chosen answer excluded interpreting the remainder. And obviously, that's something that we can talk to kids about. Guys, when you get two answers that are right next to each other like that, that's a little sus. And so that should make them think, okay, they're doing something with the remainder here. Typically, answer selections are a little bit more off, right? They're a little bit more distance like the A and C. So what can we do? Practice drawing representations in multiple ways. Arrays, strip diagrams, pictures. Whenever we as educators solve these problems, we need to draw these in multiple ways because you never know which one is going to stick. Kids will gravitate towards a certain representation, but they need to know that they can solve these with representations. If they see that, that will be much more likely for them to see, oh, I've got one missing. What am I supposed to do with that? And then we need to focus explicitly on those problems. That is a standard that is called out in fourth grade. So they need to be on the lookout for these remainders, right? There's nothing wrong with telling them, hey guys, you're probably going to get at least one question on the STAAR test to where you're going to have to divide and it's not going to be enough. And they're going to ask you, what are you going to do with that remainder? We can explicitly teach them to look out for those problems. All right, so next we've got 4.3. It is 4.3e, 33%. We only had this one problem. Honestly, we need to find the fraction for mystery or sports books. So that's 2, that's 5. So it's going to be 7 over, then I've got an extra 4 there. So 7/11ths. That's it. But I think the most difficult thing about this is the actual equation editor on the STAAR test. You have to hit this fraction button first, and then it generates a fraction. Then you have to type in 7. Then you have to hit the denominator area, which is going to be a dark gray box. Then you have to type in the 11. If you type in the 7 first and then hit the fraction bar, it's going to think you're wanting to make a mixed number. So it's not that intuitive. We only had 33% correct. We don't know what incorrect answers are. They don't give us that on the item analysis report. That equation editor definitely takes away the security of multiple choice. It's not that intuitive. And then you still had to add, you had to do a little bit of work. You had to add mystery and sports book for the correct numerator. So I would highly suggest if you have an outside resource, an outside program that has an equation editor that's exactly like this, practice. If not, get on the STAR platform, get to that test, whether it be, the 2023 release STAR test. You can look at the redesign practice, whatever it is, and don't even solve the problem. Just have the kids practice generating on that problem. Can you make a mixed number? Can you make an improper fraction? Can you make a proper fraction? Give them the opportunity to build those just so they know how the actual equation editor works. Next, we're looking at 4.5a. This is representing multi-step problems using strip diagrams and equations, and you have a letter standing for an unknown number. So what are we doing here? Well, we've got this flower shop right here, and you see that the flower shop had 242. roses. And it sold 128, right? So we're going to subtract those two, right? So we've got 242 minus the 128 because you sell it. We actually need to go ahead and do that, so let's do it vertically. 242 minus 128. That's going to be 114. Okay, so that gets you your 114. Then on Monday, the shop got some more. Now it has 150. So, right, so it got some more, and then R is the number, so it has more plus the 114 equals the 150. How could we actually solve for that, though? Well, we could actually just take this and do a fact family, right? We can take our 150, we could subtract the 114, and that's going to get us our R. And that's what we see here on C, though we do see that A is exactly the same, except that it uses plus rather than minus. So that's going to be the highly chosen incorrect answer. And we got number 18, and it's very tricky. Look at this. Paid $44, okay, and all of these are totals of 44, so that's not going to help us. Two adult tickets and three child tickets. Two adult tickets cost a total of 20, okay? So there's only 120. And then you get three child tickets, you want to find that. So I've got my three child tickets, one, two, three right there. But take a look at this. This has got two 20s. And a lot of students are going to choose that one. Correct answer is B because you've only got that 120, even though we know that's going to be split between two adults. So let's see what this means for us as educators. Okay. So for that first problem, option A, the one that used the plus, was chosen basically just as much as the other one. So the students got all the way down here and they didn't know how to figure this out, whether it's a plus or a minus. I highly suggest using strip diagrams if that's going to uh, be helpful for them. And for number 18, option D was chosen more than the correct answer. Option D was chosen 46% of the time, as opposed to 32% for this. And it's because they really geared on this two adults. But if the two adults had a total of 20, right, then you don't need the 20 twice, because then that'd be a total of 40. So we need to have students solve each problem and then substitute in the answer for the variable. Go back and double check their work. Draw representations, strip diagrams, pictorial representations, and then double check your work with the answer rather than simply trying to find the correct sequence. All right, so here's a perfect example. If we did 20 and 20, that's 40 bucks. Okay, so that only leaves $3 to split among the three kids. That doesn't make a lot of sense if you're going to buy tickets for a $20 adult ticket and a $1 child ticket, right? This leaves 24 bucks, so this actually equals $8 each, okay? And remember, this is the adult tickets of $10 each. So two adult tickets for $10 each, three children's tickets for $8 each. That makes more sense, right? That passes the smell test. So we need to have our students actually solve the problem and then just see, does that make reasonable sense? All right, 4.2G, we are at 41% overall mastery relating decimals to fractions, okay? So we had 45% full credit, right? So we needed the whole number here, 79, and then we needed the 4. And then I think the difficult thing here was getting that inline choice down there. The options here were 10, 100, I believe it was 440, and 400 were the choices, I believe. And so um, that's how we get that. We had 45%, and then if you had the, if we had the partial credit, that's 71%. That at least got 1 point. And I think this is kind of the sticking point, but that is kind of a big whole number. If anything, we're used to a single digit whole number, so that could have messed them up a little bit. Now, 28, look at this. You have to find the decimal that's equivalent to that, but it's an improper fraction, right? So we're going to go to the hundredths place. So here's my hundredths place. I'm going to build in 170. So I always put my last digit in the hundredths place. Here's my hundredths place. So there's my 0 for 170. You build it like this, you get 1.70, but that's not even the answer. Now I've got to drop the 0, and I need to find 1.7. That's tricky. So what does that mean for us as educators? Well, it was difficult because the inline choice each, had three fields, each with four choices. They had to convert the improper fraction to the decimal in the second one. And then the correct answer for 28 showed the place value only going to the tenths digit, whereas they gave you up to the hundredths digit. And then the both questions involved a whole number and a decimal, right? We're beyond the point of saying, all right, guys, what's this as a decimal? Or let's change this to a fraction. If you want to change that to a fraction, change it to an improper fraction. But those are a little bit simpler than what we're getting here on the STAAR test. So we need to practice converting decimals to fractions that involve whole numbers, right? And we need to change it both as a mixed number and improper fraction. We need to convert these decimals to mixed numbers. We need to practice converting improper fractions to decimals that include dropping a 0, which is what we just got on that second one, right? So 30, I don't know, 30 tenths, right? How would how would we do that? Well, 30 tenths. There's my tenth spot. There's my 0. There's my 3. That's just a 3. Your answer is going to be 3. You don't need a 3.0. But that's going to look a lot different than 3.0. So give our students this practice of not just converting decimals to fractions, but what happens when they're improper fractions, mixed numbers, and you need to drop a 0. All right, 4.3D, we got 45.5% overall mastery. Comparing fractions. Now, this is just difficult because, first off, this is a mixed number. I need to change this to an improper fraction, which actually the improper fraction is 13 ninths. So that's not an answer because 13 ninths is not greater than 13 ninths. But now, there's no way to do this visually. I just need to find common denominators, okay? Right? So I've got my 1 and 4 ninths, that's 13 ninths. So I'm going to find the least common denominator between ninths, and I'll go for 11/6, right? So I need to change them into 18ths. So times something equals 18. That's going to be 2 over 2, that's 26. And that's going to be times 3 over 3. But this is just a big algorithm that the kids need to get used to, right? And we do see that this 11/6, 33/18 is bigger than 13 ninths. We can go on, but that's going to be our biggest one right there. And then we need to find two fractions that are less than this fraction. Okay, so this is 8 tenths, but we also need to see this as fifths, right? And so this is also 4/5. That's going to help us. The visual makes it a little bit easier because look at this, 52% full credit, 38% partial. That's 90% with at least 1 point. So we need fractions that are less than this, right? So obviously 7 tenths. But now if I see this as 4/5, I can also say 3/5. So the visual really makes that helpful. But even if we were to draw visuals on number 26, I mean, you got ninths, you got sixths, you got 11ths, thirds. Yeah, that's not happening. All right, so we had to convert that, 1 and 4 ninths into 13 ninths. And then those fractions had to be converted to equal equivalent fractions with no visual references. So they need to practice the algorithm of finding the least common denominator, right? How do you find the least common denominator of 3 and 9 or of 6 and 9, right? Those are going to be slightly different. So they just need to practice finding the least common denominator. And then they need to practice that algorithm of using the least common denominator to generate equivalent fractions. The way I teach it, and let's say I want to change my 1/3 into 16ths or into 18ths. So I would say 1/3 times something equals, and then what is my denominator? 18ths, right? So that is going to be 3 times 6 times 6, right? So I set it up side to side so they can see what they're trying to get to. And then this last part was this visual, right? So you could have used this visual, like I said, it once they see it like this, okay, I've got my fifths, so I'm good to go. So if they give you the visual, sometimes you can use that. Next, we're looking at 4.4a, 46% overall mastery. We just need to add and subtract whole numbers and decimals. And so we see here in November, we've got 92,721. That number was greater than, right? So we're going to compare. So that means we need to subtract. It means we need to regroup quite a bit. So if we can do that, we can find our answer, but just for laughs, let's see what happens if we add them. Because if you are a student and you're not sure which way to go, well, take your numbers and add. And guess what we're going to find? We're going to find that is one of our answer choices right there. Only 46% of our students got this correct by choosing the correct operation. So students had to identify correct operation from real world context here. They had to figure out that they needed to subtract without any, big keywords. Greater was the only kind of clue they had there. And then that option C, right, that 43% was chosen almost as much as the correct answer, 46%. So almost as many students uh, decided that they needed to add as needed to subtract. And so we probably wanted to represent this with a strip diagram, right? Because if we create this with a strip diagram, let me show you what I'm talking about here. So let's go back here and let's say, okay, 92,721. Okay, so let's make that in our strip diagram right there. And that was 14,729 greater. Okay, so we can say, I'm going to do it kind of like this. And we're going to say 14,629. Then the number of people who went in October. So how many people went in October? Well, we can see that we have kind of a part whole here. And so we can use subtraction to figure it out. That visual representation might have helped some students. Um, and, we can kind of compare this with another standard and have them generate these equations and then use a letter to stand for the unknown quantity, right? We could have used like, attendance A for attendance or something like that, and then check their work by substituting. Because if we were to take this answer right here, how many people went to the stadium in October? Well, even if we had this representation and we went with their incorrect answer, 107,350. Does that make sense? Nope, this is bigger than this. But this 92,721 was 14,629 greater than, and now that doesn't make any sense. So giving them that visual representation, that language in order to justify their work, can help them eliminate those incorrect answers. So 4.7C is our last one we're going to be looking at. 50% overall mastery. We're trying to measure angles, in this case 160 degrees. So this first option is one of our correct answers. It's pretty simple. You got one ray on the 0. It opens up, goes straight to that 160. The other one here is going to be this one. It's going to go from 10 over here to 170 if I'm measuring right on the inside. And you have to find the difference to find your 160. And you see that we had 50% full credit, that's 2 points. We had 39% with partial credit, 1 point. So that's not bad. That's 89% at least getting 1 point, which most likely was this one. So what can we do to get even more students for the full credit? Well, we have to realize that the multiple select makes it a little bit more difficult, removes any type of certainty you might have for multiple choice. And then one correct solution, like I said, that first option is pretty simple. But the other correct selection, the one that was the fourth selection, didn't have that ray line on either, the 0, the 8, or on the 180 line, or on this. They had to find that difference between the 10 and the 170. And then honestly, it's kind of hard to see, but the rays do cover up the numbers in the protractor. They kind of have to use context clues on either side to see what number it's actually saying. So we can show students how to eliminate answer choices. We didn't do this, but look, you're looking for 160. If they know that your right angle is 90 degrees, then your 160 is going to be pretty big. It's going to be obtuse, right? It's going to be an obtuse angle, which means let's get rid of that one and let's get rid of that one. Those are two acute angles. We could have immediately eliminated 2 of the 5 answers and had to only choose 2 out of the last 3. That would have greatly increased our odds. And then practice measuring angles with neither ray on the 080 line by subtracting. That's just the trick on this one, right? You have to subtract 2 different numbers in order to find the measure of the angle if neither ray is on the 180 line.